Consider different charges Q1, Q2 and so on. If they are occupying certain positions in the presence of the external electric field, work has to be done in configuring this system of charges. ಇಲ್ಲಿ external electric field non-zero ಇರ್ತಾ ಇದೆ. In the presence of the external electric field, ಚಾರ್ಜಸ್ ಅನ್ನ ಅವುಗಳ ರೆಸ್ಪೆಕ್ಟಿವ್ ಪೊಸಿಷನ್ ನಲ್ಲಿ ತಂದು ಇಡಬೇಕಿದ್ರೆ ಎಷ್ಟು ವರ್ಕ್ ಆಗ್ತಾ ಇದೆ ಅದು ಸಿಸ್ಟಮಿನ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಆಗಿ ಸ್ಟೋರ್ ಆಗಬೇಕು. Hi, I'm Jagdish Naik, your physics tutor. In this video, we are going to discuss about the potential energy of system of charges in the presence of external electric field. Previous ವಿಡಿಯೋದಲ್ಲಿ ನಾವು in the absence of the external electric field ಒಂದು ಸಿಸ್ಟಮ್ ಆಫ್ ಚಾರ್ಜಸ್ ಅನ್ನ ಕನ್ಫಿಗರ್ ಮಾಡಲಿಕ್ಕೆ ಎಷ್ಟು ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಸ್ಟೋರ್ ಆಗ್ತಾ ಇದೆ ಅದನ್ನ ನೋಡಿದ್ದೇವೆ. ಬಟ್ ಹಿಯರ್ we are going to consider the presence of the external electric field. Therefore, even when we are bringing the first charge from infinity to its respective position, external field irta iroದ್ರಿಂದ we have to do the work against the external field. Therefore, the work done in bringing the first charge from infinity to its respective position is not zero. Let us assume that in this region there is an electric field due to the unknown source. External electric field under meaning adu. Only we need to know there is an electric field due to some unknown sources. Because of that external field, the position A where charge Q has to be brought from infinity. ಒಂದು ಪೊಟೆನ್ಷಿಯಲ್ ಇದೆ ಅದನ್ನ ನಾವು V of R ಅಂತ ಬರೀತಿದ್ದೇವೆ. Where R is representing the location of the charge Q with respect to some origin. Let us consider the point A. From infinity, the charge Q is slowly brought without acceleration to the position A. Since there is an external electric field, the work has to be done. That amount of work done is non-zero quantity. And we already know that in order to find out the work done, we need to consider the product of charge and the potential at a point where the charge is brought from infinity. External field E ದಿಂದಾಗಿ ಪಾಯಿಂಟ್ ಎ ದಲ್ಲಿ ಇರುವಂತಹ ಪೊಟೆನ್ಷಿಯಲ್ ಅನ್ನು ನಾವು V of R ಅಂತ ಬರೀತಿದ್ದೇವೆ. Hence the work done will be is equal to Q into V of R. This will be stored in the form of potential energy. Hence the expression for the potential energy of a single charge in the presence of the external electric field is represented as Q into V of R. ಇಲ್ಲಿ determination of the potential energy for a single charge is not important. We only need the expression representing the potential energy of single charge in the presence of external electric field. You can take the screenshot of this slide. Now let us consider system of two charges Q1 and Q2. They are placed at a position A and B at a distance of separation represented as R12. ಇಲ್ಲಿ external field E ಇರ್ತಾ ಇರೋದ್ರಿಂದ at position A the potential is represented as V of R1. Whether Q1 present ಇರ್ಲಿ ಅಥವಾ ಇಲ್ಲದೆ ಇರ್ಲಿ external field ಇಂದಾಗಿ ಇಷ್ಟು ಪೊಟೆನ್ಷಿಯಲ್ A ದಲ್ಲಿ ಹಾಗೆ ಪಾಯಿಂಟ್ B ದಲ್ಲಿ Q2 ಅಬ್ಸೆಂಟ್ ಇದ್ರು V of R2 ಜನರೇಟ್ ಆಗಿರಬೇಕು. ಇಲ್ಲಿ R1 and R2 are representing the position of Q1 and Q2. Now, as usual, we are going to bring charge Q1 from infinity to position A. Infinitesimal is low without acceleration. Now Q1 ಅನ್ನ position A ಗೆ ತಂದಿರ್ತಾ ಇದ್ದೇವೆ. Therefore, the amount of work done in bringing charge Q1 from infinity to position A is not equal to 0. Second charge Q2 ಅನ್ನ infinity ಇಂದ position B ಗೆ ತಂದಿಡಬೇಕಿದ್ರೆ there will be two electric field. ಒಂದು external electric field ಇಲ್ಲಿ ತೋರಿಸ್ತಾ ಇರುವಂತದ್ದು ಜೊತೆಗೆ ಚಾರ್ಜ್ Q1 ಇಂದಾಗಿ ಒಂದು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಕ್ರಿಯೇಟ್ ಆಗ್ತಾ ಇದೆ. ಅಗೇನ್ಸ್ಟ್ ಬೋತ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ಸ್ ನಾವು Q2 ಅನ್ನ ಎಕ್ಸ್ಟರ್ನಲ್ ವರ್ಕ್ ಮಾಡಿ ಪಾಯಿಂಟ್ B ಗೆ ತಂದಿಡಬೇಕಾಗುತ್ತೆ. Therefore, the work done in bringing the second charge W2 is also non-zero quantity. let us find out the value of W1 and W2. Previous example li observe ಮಾಡಿದಾಗೆ W1 should be is equal to the product of charge Q1 and the potential at point A due to the external field V of R1. We need to consider the potential at B. Let us represent it as a VB. ಯಾಕಂದ್ರೆ VB is net potential due to the external field and also potential due to the charge Q1 present at a distance of R12 from point B. That means V of R2 and potential due to the charge Q1 ಎರಡನ್ನು ಸಮ ಮಾಡಿದಾಗ we will get the expression for the VB. Therefore, the work done W2 must be equal to the product of Q2 into VB. Again, VB will be equal to the potential at B due to the external source VR2 and potential at B due to the charge Q1 1 by 4 pi epsilon naught Q1 by R12. VB value ಅನ್ನು substitute ಮಾಡಿದಾಗ we will get W2 is equal to Q2 into VR2 plus 1 by 4 pi epsilon naught Q1 Q2 divided by R12. Since we have determined the expression for W1 and W2, the total work done in configuring the system. Charges ಅನ್ನು assemble ಮಾಡ್ತಾ ಇರಲಿಕ್ಕೆ ಆಗ್ತಾ ಇರುವಂತ total work done will be is equal to sum of W1 and W2, which is stored in the form of the potential energy of the system. We know that W1 is equal to Q1 into VR1, W2 is equal to Q2 into VR2 plus 1 by 4 pi epsilon naught Q1 Q2 divided by R12. Hence, total potential energy of system of two charges in the presence of external electric field is given by this equation. The notes for the determination of expression for the potential energy of system of two charges in an external electric field is as shown in the slide. Exam point of view dalli this equation is important. ಇಲ್ಲಿವರೆಗೆ derivation ಅನ್ನ ಕೇಳಿಲ್ಲ but expression ಅನ್ನ ಕೇಳಿದ್ದಾರೆ. You can take the screenshot of this slide. Next concept is to determine the expression for the potential energy of an electric dipole when it is placed in external electric field. Electric dipole is a system of two equal and opposite charges separated by a small distance, which is represented as 2a. The line joining the position of positive and negative charges is known as the axis of the dipole. ಇದು axis of the dipole. ನಮ್ಮ ಕನ್ವೀನಿಯನ್ಸ್ಗೆ ನಾವು ಇಲ್ಲಿ ಯೂನಿಫಾರ್ಮ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಿದ್ದೇವೆ. It is represented by equally spaced parallel lines. This dipole is placed in a such a way that its axis is making an angle theta with respect to the direction of the electric field. We know that whenever a dipole is placed in a uniform electric field making an angle theta with respect to the direction of the electric field, then it will experience a torque represented as tau theta. Torque ಅನ್ನು ನಾವು already previous chapter ಅಲ್ಲಿ determine ಮಾಡಿದ್ದೇವೆ. I will give the link for the video both I button ಅಲ್ಲಿ ಹಾಗೂ description box ಅಲ್ಲಿ ಲಿಂಕ್ ಅನ್ನು ಪ್ರೊವೈಡ್ ಮಾಡಿದ್ದೇನೆ. Please watch that video. We know that the expression for the torque is represented as 2aq into E sin theta, where 2a is the distance of separation between the two charges of the dipole, q is the magnitude of either of the charge, and E is the electric field. Since 2aq is equal to the dipole moment P, the expression for the torque can be represented as Pe sin theta. ಇಲ್ಲಿ ನಾವು magnitude of the torque ಅನ್ನಷ್ಟೇ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೇವೆ. If you are going to rotate this dipole through a very small angle d theta, we have to do the work, and that amount of work done is given by the above expression. dW is equal to tau theta into d theta. Substituting the value of tau theta, work done is given by Pe sin theta into d theta. ಈ ಡೈಪೋಲ್ ಅನ್ನ in the presence of external electric field ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಆಂಗಲ್ ಇಂದ ಇನ್ನೊಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಆಂಗಲ್ ಗೆ ರೊಟೇಟ್ ಮಾಡಿದಾಗ ಟೋಟಲ್ ಅಮೌಂಟ್ ಆಫ್ ವರ್ಕ್ ಡನ್ ಎಷ್ಟಾಗಿದೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಸಿನ್ಸ್ ದ ಟಾರ್ಕ್ ಇಸ್ ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ದ ಆಂಗಲ್, ಥೀಟಾ ಚೇಂಜ್ ಮಾಡ್ತಾ ಹೋದಾಗ ಟಾರ್ಕು ಚೇಂಜ್ ಆಗಬೇಕು. Therefore, by small angular displacement, the torque is remaining almost constant. ಇಲ್ಲಿ ವೇರಿಯಬಲ್ ಫೋರ್ಸ್ ರೀತಿ ವೇರಿಯಬಲ್ ಟಾರ್ಕ್ ಅಪ್ಲೈ ಆಗ್ತಾ ಇರೋದ್ರಿಂದ ನಾವು ಇಂಟಿಗ್ರೇಷನ್ ಮೆಥಡ್ ಯೂಸ್ ಮಾಡಿ ವರ್ಕ್ ಡನ್ ಅನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತಾ ಇದ್ದೇವೆ. ಟೋಟಲ್ ವರ್ಕ್ ಡನ್ in rotating the dipole through an angle theta is represented as integration of dw, where dw will be is equal to integration of pe sin theta into d theta. ಇಲ್ಲಿ p and e are constants which are independent of the angle of rotation. ಅದನ್ನ ನಾವು ಇಂಟಿಗ್ರೇಷನ್ ನ ಸೈನ್ ಇಂದ ಹೊರಗಡೆ ಬರೀತಿದ್ದೇವೆ. Hence w should be is equal to pe into integration of sin theta d theta. Initially, dipole is making an angle theta 1 with respect to the direction of the electric field. Then rotate ಮಾಡಿದ್ಮೇಲೆ finally it will be making an angle theta 2 with respect to the electric field E. Sin theta ವನ್ನು integrate ಮಾಡಿದಾಗ we will get minus cos theta. Hence the work done must be is equal to minus PE cos theta. ಇಲ್ಲಿ upper limit theta 2 ಇದೆ, lower limit theta 1 ಇದೆ. Values ಅನ್ನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ we will get the expression for the work done W is equal to minus PE into cos theta 2 minus cos theta 1. Students, here it will be more convenient to consider a reference direction. ಅಂದರೆ ನಾವು theta 1 ಅನ್ನ particular direction ಅಲ್ಲಿ ಫಿಕ್ಸ್ ಮಾಡಿದಾಗ it will be more useful. The initial angle theta 1 will depend on the choice of the observer. The best choice is theta 1 is equal to 5/2. ಯಾಕಂತ let us observe. When we draw a line perpendicular to the direction of electric field, ಇಲ್ಲಿ ಯೂನಿಫಾರ್ಮ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇರ್ತಾ ಇರೋದ್ರಿಂದ ಈ ಯೆಲ್ಲೋ ಲೈನ್ ಪ್ರತಿಯೊಂದು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಗೂ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿದೆ. While discussing the properties of the equipotential surface, we know that equipotential surface ಗೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ ನಾರ್ಮಲ್ ಆಗಿರಬೇಕು. ಆದ್ದರಿಂದ this yellow line is representing the equipotential surface. Initial angle of the dipole with respect to the electric field theta 1 is equal to 90 degree. ಅಂದರೆ ಇವೆರಡು ಚಾರ್ಜಸ್ ಮೈನಸ್ ಕ್ಯೂ ಇರಬಹುದು ಪ್ಲಸ್ ಕ್ಯೂ ಇರಬಹುದು, ದೇ ಆರ್ ಲೈಯಿಂಗ್ ಇನ್ ದ equipotential surface. ಇನ್ಫಿನಿಟಿ ಇಂದ ದೀಸ್ ಟೂ ಚಾರ್ಜಸ್ ಪ್ಲಸ್ ಕ್ಯೂ ಮತ್ತು ಮೈನಸ್ ಕ್ಯೂ ಅನ್ನ ಇವೆರಡು ಪಾಯಿಂಟಿಗೆ ತಂದು ಇಡಲು ಎಷ್ಟು ವರ್ಕ್ ಆಗ್ತದೆ ಅಂತ ಹೇಳಿ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಂದ್ರೆ let us assume that the potential at this equipotential surface is represented as V. It should be same throughout the surface. The work done in bringing the positive charge from infinity to its position on the equipotential surface is represented as W1, which will be is equal to Q into V. Similarly, minus Q ಅನ್ನು ನಾವು ಇನ್ಫಿನಿಟಿ ಇಂದ ಸೇಮ್ equipotential surface ಅಲ್ಲಿ ಡಿಫರೆಂಟ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ತಂದು ಇಡಬೇಕಿದ್ರೆ the amount of work done is represented as W2, that should be is equal to the product of charge, negative charge in the minus Q into V. Potential due to the positive charge is positive, that due to the negative charge is negative. Total work done in assembling these charges, W must be is equal to W1 plus W2, that should be is equal to QV minus QV, which is equal to 0. Therefore, when we choose theta 1 is equal to 90 degree, the potential energy of the dipole when axis of the dipole is perpendicular to the electric field is equal to 0. ಆದ್ದರಿಂದ ನಾವು theta 1 ಅನ್ನ 5/2 ಅಂತ ಅಸ್ಯೂಮ್ ಮಾಡ್ತಿದ್ದೇವೆ. If we rotate the dipole from this position through certain angle, which is making an angle theta with respect to the direction of the electric field. That means if theta 2 is equal to theta, ಎರಡು ವ್ಯಾಲ್ಯೂಸ್ ಅನ್ನು ನಾವು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ we know that cos 5/2 is equal to 0. Hence the expression for the work done will become minus PE cos theta. Since both dipole moment and electric fields are vector quantities, and work done is scalar quantity. ನಾವು ಇದನ್ನ ಮೈನಸ್ ವೆಕ್ಟರ್ ಪಿ ಡಾಟ್ ವೆಕ್ಟರ್ ಇ ಅಂತ ಬರೀಬಹುದು. So this amount of work done will be stored in the form of potential energy of the electric dipole. Finally, the notes for the same. You can take the screenshot of this slide. If you have found this video useful and also informative, please like my video, ನನ್ನ ಚಾನೆಲ್ ಅನ್ನು ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ, and also share these videos with your friends and relatives. Thank you for watching this video.